गुड मॉर्निंग एवरीवन। नमस्ते बच्चों, हमेशा खुश रहो बच्चों। माई सेल्फ ओम प्रकाश केसरी, फैकल्टी ऑफ डिपार्टमेंट ऑफ मैथमेटिक्स अंडर फैकल्टी ऑफ एजुकेशन एंड मैथोलॉजी, ज्योति विद्यापीठ वुमेन्स यूनिवर्सिटी, जयपुर, राजस्थान। Today I taught you group theory, in which I will see one new concept known as complexes or and subgroup of a group. The group theory is the subject of mathematics which are taught in BSc, BEd, PCM 6 semester student. These are the lesson planning which are already taught in your first lecture. These are the step for planning a lesson which are already taught in your first lecture. These are the components of a lesson plan which are already discussed in your first lecture. Now, group theory is a subject of mathematics under science stream which are taught in BSc, BEd, PCM 6 semester student. Complexes of a group. I will see the definitions of a group. Now, the definition of a group is if G is a non-empty set equipped with the binary operation star or O or anything which are binary operation and satisfy the some axioms such as closure axiom, associativity, existence of identity element and existence of inverse. Then we say that G is a group. The complex of a group is nothing but the subset of a group. Let G be a group with respect to the binary composition star. Now, any non-empty subset H of a group G is called a complexes of a group. Any non-empty subset H of a group G is called complexes of a group. That means if H is the subset of G, then H is a complex of a group of G. But remember that H must be non-empty. Let H be a non-empty subset of a group G. Suppose H is closed with respect to the binary composition O in G. That is A belongs to H, B belongs to H implies that A, O, B belongs to H. Then we say that the complex H is stable for the binary composition O in G, and the binary composition in G has induced a binary operation in H. Thus, binary operation in H is called the induced composition or induced binary operation. Thus, the binary composition in H is called the induced composition or induced binary operation. Induced binary operation. Now, our next topic is subgroup. This is very interesting group. Don't confuse subgroup as a semigroup. Semigroup is the different things and subgroup are different things. Let G be a group with respect to the binary composition star. Take any non-empty subset H from G, that means complexes of H from G. We say that H is a subgroup of G. H is a subgroup of G if H is closed with respect to the binary operation star of G, and hence H is itself a group with respect to the binary operation star. With respect to the binary operation star. That means if G is a group and we can take any complexes of G which are non-empty if G is H is a subset of G which are non-empty, that means H a non-empty subset H of G which is a complex of G, and it also follow the properties of group. That means closure axiom satisfies, associativity satisfy, existence of identity element satisfy, existence of inverse satisfied. All these four properties are satisfied. Then obviously H satisfies closure axiom. Then the operation on H, that means star, is said to be induced binary operation in H. Said to be induced binary operation in H. And H is also stable. Just see the definition. H is stable for the binary composition star in G, and the binary composition in G has induced a binary composition in H. That means subgroup follow all these properties with respect to the binary operation star on G. And we can say that H is itself a group with respect to the binary operation star. Now, here some notable points are the every subgroup of G is a complex of G, but every complex of G is not always subgroup of G. Every subgroup of G is a complex of G, but every complex of G need not be subgroup of G, because if that complex satisfies the property of a group, then that subset is said to be group subgroup of a group G. Since every set is a subset of itself, hence every group is the subgroup of itself. This is very important line. That means we know that it's a basic concept from set theory. The every subset set is the subset of itself, or we can say empty set and the set itself is the subset of itself. Empty set is the subset of every set, and every set is the subset of itself. Now, one theorem are there. The theorem is the identity element E of a subgroup is the same as that of the group. The identity element E of a subgroup is the same as that of the group. That means I will see in your previous theorem that identity element must be unique. That means G has a unique identity element, and H, the identity element of H subgroup is also the identity element of a group. That means the one element identity element must be there in a subgroup of a group G. Must be there in a subgroup of a group G. We have to prove these things. That means prove that the identity element of a group is same as that of a group. Prove that the identity element in a group is same as that of the group, which we have to prove. The proof is simple. The identity element E of a subgroup H is the same as that of the group. For this, we can construct a group. After that, we can also construct a subgroup of a group G. Let G star be an algebraic structure which follows the properties of a group. Then we can say let G star be a group, and let H star be a subgroup of a group G. Then if possible, E and E dash be the identity element of G and subgroup H of G respectively. Now take an element A belongs to H. Take an element A belongs to H. Therefore, we can say that we have to prove that equals to E dash. We have to prove that equals to E dash. For this, I will see the proof of this theorem in your next lecture. This session is powered by the digital version 2.0 JAYOTI VIDYAPEETH University, Jaipur, and I hope all of you are satisfied with my digital session. If you have any queries, please mention in the comment box. I will try to resolve it. Thank you for watching my this lecture video. Thank you.